Alright, welcome. In this video, I'm going to be doing some more Algebra 2 reviewing on Unit 9. This video is going to be about applied contexts of exponential functions and recursive formulas. Really going to this particular TEK for Texas Algebra 2, where we need to formulate exponential and logarithmic equations that model real-world scenarios, including exponential relationships written in recursive notation. I don't even remember noticing this the last time I taught Algebra 2, but I put some of these questions on one of the quizzes, and y'all said that you kind of had a tough time with them, so I figured I'd give you some more practice. Okay, so the first one is Mr. Yost purchasing a new computer for $1,750. Okay, the depreciating value of the computer over time can be represented by the recursive formula A1 is 1312.5 and AN is 3/4 of AN minus 1. Okay, what that means is that after 1 year, I'm going to actually write this out. After 1 year, value is 1312.50. And this second equation here means that for a given year, the value is 3/4 of the value of the year before. Okay, so each year that goes on, your value is getting multiplied by 3/4, which means it's getting smaller. Okay, so what equation can be used to model the value of the computer? V of t is going to be some starting value, right? It's going to be a times b to the x, where a is some sort of starting value and b is some sort of multiplier. Okay. And if they're giving us a recursive formula, they're usually just giving us the number that we need to multiply by each time, and that's 3/4. So b is 3/4, and a is going to be 1,750. Okay, so 1750 times 3/4 to the x, or t, yeah, it's definitely v of t. T is the independent variable. That's going to be S choice B. Okay. Then a culture of 3,000 bacteria quadruples in number every 10 hours. P of t represents the population of the bacteria after t hours. Which equation is best representative of this? All right. So I think that what I'm going to say is that after 10 hours, okay, so when t equals 0, we need to have 3,000 bacteria. When t equals 10, it should have quadrupled, right? So it should be 3,000 times 4 is 12,000. And then we probably need to be quadrupling every 10. I'm telling you, A is looking pretty appealing to me, okay? Because I know that when t equals 10, I need to only be multiplying by 4. And that would be happening if I had 4 to the 10 over 10 is 4 to 1. So I'm thinking A, but you might be saying, well, why not C? Okay, if you plug in 10, that'd be 3,000 times 4 to the 10 would be too many bacteria, right? Too many to fit. And so it's going to be this one. And then it asks, right, a recursive formula for the population at n 10-hour time intervals. So this one's kind of, I wanted to make as many recursive formula questions as possible, but kind of hard when it was one of these where it was quadruples every 10 hours. So we're just going to say n is a 10-hour time interval. So at the beginning, it's 3,000. So I'm going to say A0 equals 3,000. And AN is going to equal, well, 4 times AN minus 1. Okay, the amount of bacteria at this 10-hour time point is going to be 4 times what it was at the previous 10-hour time point, 10 hours ago, is what we're saying. So that's really my recursive formula right here. Now, number 3 is kind of an applied log equation, which we didn't really do in class, in the notes, on the homework, or on the quiz. So it's probably a safe bet that it's not going to be something I'm going to ask you to do on the test. But I figured if you were here doing some extra practice, you might be the type of student that could gain a little bit of something from this. So the magnitude of an earthquake is measured using the Richter scale. Scale uses a base 10 logarithm that compares intensity of the earthquake, which is I, to the intensity of a standard earthquake, S. I don't know what a standard earthquake is, but we're just going to go with it, right? So which equation could be used to determine the intensity of a 6-point magnitude earthquake compared to an earthquake of standard density? I see. All right, so M is going to equal log base 10 of I will be 6.3 over S. Okay, and this is also equal to log base. I didn't look at this problem first. I tell you, I don't much like this problem. But maybe it's because I'm just not totally seeing what I'm supposed to do. Okay, I'm going to definitely use a log property here. I can see that that's what it's going for, right? We're taking like things adding together. So I think it's going to be log base 10 of I over s is going to be log base 10 of I minus log base 10 of s. And that's going to be equal to let me think. I'm going to pause and think about this. I feel like I'm stumped. Yeah, that would be because I kind of misread the question. The magnitude is 6.3. Okay, so let's just ask for your forgiveness on that one. It's kind of a blunder. Just hadn't read the question first. I can just figure it out. Okay, I guess I could have figured out had I plugged in the right thing. Okay, 6.3 magnitude is 6.3 equals log of I minus log of s. So if I was looking to solve for log of I, which is what it appears they're wanting me to do, I would add a log of s to both sides, and I'd have 6.3 plus the log of s equaling the log of I. Okay, so 6.3 plus the log of s equals the log of I. That's A. Okay, that was tough. Let's move on. All right, number 5. Researchers are collecting data to study the destructive effects of Texas oat wilt disease. Okay. Data is being collected on the number of non-infected oak trees remaining on a section of land as a function of time. We've got this recursive formula. Okay. I think we're going to need unless something really good is going to happen with arithmetic, I think if we keep dividing in half, I might need a calculator eventually. So the first 5 terms of the sequence. Okay, so A1 is so we need A1 through A5. But I think in the other one we assumed A0 was kind of the starting point, so I'm going to do the same thing. We're going to say that time 0 would be, A0. To get to A1, which is 1,536, I divided by 2. So to go backwards, I would multiply by 2. That would be 3,000 from here and 72. Okay. If I divide 1,500 by 2, I'd get 750. And then if I divided 36 by 2, I'd get 18. So I've got 750 plus 18 is 768. Okay, dividing 768 by 2 might not be the easiest thing ever, but I'm kind of committed to doing this without a calculator, at least this one. I'm thinking A3 will be, half would be like 350 to 700. But it would probably be 380 to get to 760, so I'm thinking 384. And then A4 would be half of 384, half of 380 would be 190, I think 192. This has worked out all right. This wasn't that bad on an arithmetic level. Formulate an exponential equation to model the number of non-infected oak trees remaining on this section of land as a function of time. Okay, well, n of t is going to be some starting value, which I'm going to call 3,072. And times some multiplier to the t. Well, each time, I'm multiplying by a half, so that multiplier will be 1/2. That'll be an exponential equation. And what I want to point out, if you're here 10 minutes in, about this would be good for if we needed to approximate the number of non-infected oak trees remaining at a time that wasn't a whole number. Right, that would be what this formula would be good for. Whereas this one would be good for if we knew that at 6 years it was this, what's going to be at 7, we just multiply by half. Okay, so both of these formulas, recursive, explicit, they're kind of each good in their own situation. Okay, so part C, if the Texas oat wilt disease continues to affect the oak trees on the section of land, determine the number of years, so it appears that T is measured in years. It's the first time they've said that. It will take for the number of non-infected oak trees remaining to decrease to half a dozen trees. Interesting. I would not use that terminology, half a dozen trees. But, this did come from Texas Education Agency, their resource system so that's where I went, looked up that TEK, and was like, hey, give me some problems, and it gave me these. So remember, that's going to be n equals 6. Okay, that's half a dozen. Dozen's 12. We have not talked about a dozen in my Algebra 2 class this year. So if you were confused, it means 6. Okay, I'm kind of conflicted here. We're not going to be solving this like algebraically with a log. That's not going to happen. We could use a calculator, but you're gearing up for a non-calculator test. I'll tell you, this kind of arithmetic is not what I would ask you to do, but I am going to just keep dividing in half and seeing what happens. Half of 192 would be, well, half of 190 is like 95. That would be 96. Yeah, 96, great. That's A5, A6. Half of 96 is 48. Okay, half of 48 is 24. Okay, so it is going to work. A8 is going to be 12, and then the last one will be half a dozen. So n equals 6, I've got t equals 9, assuming that we started at t equals 0. But actually, the way that this was set up was probably not ideal. I wouldn't be vague on you, especially on, like, say, a unit test. So the next one, population of a community north of San Antonio, hey, like us, has been doubling every year. It's not sustainable growth. I'll tell you right now, that's concerning. Okay, but it's starting off with a pretty small population. In 2015, the population was 50. In 16, the growth had taken it up to 100. That makes sense, doubled every year. And to 2017, reached 2,000, or 200, yeah. Okay. Formulate an exponential equation, and why don't we do a recursive formula as well to represent the population in that community north of San Antonio as a function of the number of years since 2015. Okay, so population at time is going to be some starting value. Okay, so starting at 2015, no years after 2015, the population was 50. Okay, we're doubling each year, so I'm going to multiply by 2 to the t, where t is the number of years. If I was to write a recursive formula for this, I would say the population at the nth year is equal to 2 times the population at the year before. And then if the population growth continues in the same, exponential equation, and then this would be a recursive formula. Thought it might be good if I labeled that. You can't even see it, but there you go. Okay, if the population growth continues in the same pattern, in what year will the population of the community north of San Antonio reach a population? That was not even well written, right? They repeated some words. I need to proofread this. That's all right, though. Plenty of things that are not well proofread. The population in the community north of San Antonio reaches 12,800. Well, I think I'm just going to be able to figure this out, right? Because in 17, it was, 200? I'm just going to keep doubling to get to, because I see it's 128 hundreds. So I think we'll be able to do that. And 18, it was 400. And 19, it's going to be 800. 1,600, 3,200, 6,400, 1,2,800. Okay, and that's the year. So this would be 2020, 2021, 2022, this year, 2023. Okay. Okay, the number of people visiting a local grocery store is increasing at a rate of 1.5% per week. I made this one up because I didn't see any percent growth. Write a recursive formula for the number of people visiting the store each week. Okay, so 1.5% growth would be like the number of people getting multiplied by 1 and 0.015. Okay, the 1 being like all those people that were showing up the week before, they're still showing up, and then there's growth at 1.5%. So I'm saying that, okay, the number of people in a given week is equal to 1 plus 0.015 times the previous week number. Now you could call that 1.015 if you wanted, and I'm probably going to do that down here when I make this an exponential formula, but I think that's fine. Okay. At the beginning of January, there were 1,000 visitors in a week. Write an exponential function that gives the weekly number of visitors at t weeks into the year. Okay, so weekly number, so the amount of customers at t weeks into the year is going to be 1,000 times the same multiplier to the t, 1.015 to the t. And, well, that's all the problems for this section of the review. Thanks for checking in with me on these. You know, if you felt like you needed more practice on this stuff and you went and did it, that will pay off. I promise you that. So thanks for watching. Hope this helped.